Video problem 94, balancing redox equations by using the half reaction method. Alright, so this one takes place in an acidic solution, so let's go through the steps. The very first step is to break the reaction into the oxidation reaction and the reduction reaction. Okay, so let's do that first. Now, the way that you do that is basically you put like things together. So I'm going to take this permanganate, MnO4 minus, and it's going to go to manganese, because, you know, they both have manganese in them. And then I'm going to take this chloride and put it by itself as well. Oops. Alright, so that's the first step, break it into its half reactions. The second step is to balance everything except oxygen and hydrogen. Manganese is balanced, chlorine is balanced. The third step is to balance oxygen by adding water. So I've got 4 oxygens here, so I'm going to add 4 waters. I've got 1 oxygen here, so I'm going to add 1 water. So now the oxygen is balanced. And now you balance hydrogen by adding protons. So I've got 8 hydrogens here. That means I'm going to add 8 protons here. I've got 2 hydrogens here, 1 hydrogen there, so I'm going to add 1 proton to this side. Now what you do is you balance the charge by adding electrons. So this is plus 8, this is minus 1, this is plus 2, this is 0. So I've got 7 is equal to 2. I need to add 5 electrons to this side, because now negative 6 plus 8, positive 2 equals positive 2. Alright, so hopefully I have to add electrons to the other side here. Let's see. I've got a negative 1, I've got a positive 1. How am I going to make those equal? I'm going to add 2 electrons to this side. So now they're equal. Okay, let's take a quick break here in identifying the oxidation reaction and the reduction reaction. So in this case, the electrons are being added. So that means that that is the reduction reaction. Okay, we can say that permanganate is being reduced. Down below, electrons are being lost, so that's oxidation. Now, if you get to this point and your electrons are on the same side, you did it wrong. Okay, electrons cannot be on the same side. Alright? One of them has to be flipped. Alright, so did the electrons. Now, the electrons have to cancel out. So what I'm going to do is I'm going to take the top reaction and multiply by 2. I'm going to take the bottom reaction and multiply by 5. So this becomes 10. This becomes 16. Get a 2 in front of there, 2 in front of there. This becomes 8. This is 5, 5, 5, and 5, and then 10. So now I cancel out what appears on both sides. The electrons cancel out. They always have to cancel out. If they don't cancel out, you're doing it wrong. Right? Now I've got 16 protons here, but on the product side I've got 5 protons. So that's going to leave me with 11 protons, 11 H pluses, on the reactant side. Right? Now, here's water. 5 waters, 8 waters. That's going to leave me 3 waters on the product side. Really, nothing else should cancel out. Right? But it might. Double check just to make sure. Don't want to assume. Okay, now it should be all balanced. So let's check. First, let's make sure that all the atoms are balanced. So what do we got? We've got 11 hydrogens, 6 plus 5, so that's 11 hydrogens, 2 manganese, 4 oxygens, that's 8. 8 oxygens, that's 3 plus 5, which is 8, 5 chlorides, 5 chlorides, chlorines. Right? So that's mass balanced. Now let's make sure it's charge balanced. So on this side we've got a plus 11, a minus 2, and a minus 5. So that altogether is a plus 4. On this side we have a plus 4. So it's mass and charge balanced. So we're done. That's a good reaction. It takes place in an acid. We can tell that it takes place in an acid because right there. Right, that's the symbol for a strong acid. That's the net ionic equation for a strong acid. The proton, the H+. Okay, let's do the one right below it. We're going to be doing the same thing, balancing it. Let's first break it up into its half reactions. I got a chromium and a chromium. So let's put those together. Cr2O7, 2 minus, yields Cr3+. Half reaction. So let's put that NO2 and NO3 together. Okay, if you want to, pause it and try it yourself. My next step, make sure everything except for oxygen and hydrogen is balanced. So I'm going to put a 2 in front of there to balance the chromiums. Everything else is balanced. Now I'm going to add or balance the oxygen by adding water. Now I'm going to balance hydrogens by adding protons. And then I'm going to balance the charge on both sides. So let's see what we got here. On this side it's plus 12. On this side it's plus 6. So let's add 6 electrons. Down here I've got a minus 1. I've got a plus 1. So that's 2 electrons. I'm going to have to multiply the bottom times 3 to balance out the electrons. So it gives me 3, 3, 3, and 6, and then 6 here as well. Okay, and now I add them both up. So my electrons cancel out. They always have to cancel out. I can see the top is being reduced, the bottom is being oxidized. I've got 14 protons here, 6 there, so that's going to give me 8 protons on the reactant side. Let's see, I've got 3 waters here, 7 waters there, so that's going to give me 4 waters on the product side. Nothing else cancels out. Let's make sure it's mass and charged balance. We've got 8 protons, 8 hydrogens, 2 chromiums, 7, 9 oxygens, 4, did I count something wrong here? Yeah, I did. That's 13 oxygens. So that's 4 plus 9, which is 13 oxygens. 3 nitrogens. So it is mass balanced. Now we need to do the charge. That's a plus 8. That's a minus 2, which is a plus 6. Over here, plus 6. So there we go. Mass and charge balance. We can tell that it's in an acidic solution because of the protons right there.